Okay, this is part 284C3M1B7C8E13C9C6D3P38D19D7b9d12. And it's line 22f1fa19C3M1b7C8E13C9C6D3P38D19D7b9d12. Cavity 1 Optomechanics 5G Wow Seti. There's the alien radio signal. This here like that. Okay, so it's Cavity Optomechanics 1 Quantum Optics Non-Classical Light Mirrors Keyword Research Light Signals for Long Distance Communication Device and Wild Data. March 23rd, 2013. Today's April the 4th. Keyword ID is a radiative energy, bilinear form, Fermi line, and Fermi Edge Singularity. Google the keywords from the data for Fermi Edge Singularities with Mesoscopic X-Ray Edge Problem and Mesoscopic Fluctuations. There's the line of data there with Optomechanical light. Keywords are Mesoscopic Fluctuations, Quantum Optics, Non-Classical Light, Glauber Sudarshan P representation, Non-Classical Light, Cavity Optomechanics. The keyword Cavity Optomechanics was from www.nature.com. And this is part 1. Quote from the blog: Cavity optomechanics is a branch of physics which focuses on the interaction between light and mechanical objects on low energy scales. It is a cross field of optics, quantum optics, solid state physics, and materials science. The motivation for research on cavity optomechanics comes from fundamental effects of quantum theory and gravity, as well as technological applications. The name of the field relates to the main effect of interest, which is the enhancement of radiation pressure interaction between light photons and matter using optical resonators, cavities. One may envision optomechanical structures to allow the realization of Schrodinger's cat. Macroscopic objects consisting of billions of atoms share collective degrees of freedom which may behave quantum mechanically, sphere of micrometer diameter being in a spatial superposition between two different places. Such a quantum state of motion would allow to experimentally investigate decoherence, which describes the process of objects transitioning between states which are described by quantum mechanics to states which are described by Newtonian mechanics. Optomechanical structures pave a new way for testing the predictions of quantum mechanics in decoherence models, and thereby might allow to answer some of the most fundamental questions in modern physics. There is a broad range of experimental optomechanical systems which are almost equivalent in their description, but completely different in size, mass, and frequency, ranging from attograms and gigahertz to kilograms and hertz. Cavity optomechanics was featured at the most recent milestone of photon history in Nature Photonics, as well as established concepts in technology like quantum information, Bell inequalities, and the laser. The typical model for many structures in cavity optomechanics is a optical cavity consisting of a fixed mirror and a mechanical oscillator. March 23, 2013, my thoughts. Looks like the obsidian mirror and laser beam formulas coming up in the WOW data. Cavity optomechanics uses a fixed mirror and a mechanical oscillator, whereas the WOW data uses a crystalline mesh lattice to diffract the electron pencil laser beam signals around the structure. The keyword Cavity Optomechanics Part 2 plus Quantum Light and Ions continues in the next video. Thanks for watching.